When it comes to working with trig, when you get to higher order mathematics, oftentimes you're put in a situation where there is a trig equation coming out of things. Trig is very real world applicable. So, sometimes the problem is that those equations aren't as straightforward as like right triangle trigonometry. Right triangle trigonometry, y'all have been able to solve that since geometry, in theory. In practice, it varies a little bit from each of you, but it's doable. As things get more complex, as you've noticed through law of sines and law of cosines, solving can get a little more complicated, and it gets more and more complicated as you go. So, having tools necessary to deal with those complicated ones is what Chapter 13 is about. Because our goal is to solve trig equations. Now, when we are solving trig equations, essentially we are solving for the angle. That's generally the unknown in the situation. So we're going to consider the trig ratio sine of theta, where it is equal to 1/2. Solving an equation like this, we've done it before, but in the context of whatever situation you're given for this, it could change what the answer looks like. If I were to simply tell you to solve this, it's really easy to solve. How do we find theta when you have an equation that looks like this? Not divide sign. How do you? Sine inverse. Sine with the little -1 that we put in front of things. Gets rid of sine. Cancel, cancel. Theta ends up being equal to what? No. Thirty. 30 what? Degrees. So if we're working in degrees, it's 30 degrees. Or, what if we were solving in radians? No. No. Pi over 6. Now that's the basic straightforward solve. That is the type of solve that you technically start learning in geometry. Now we've stepped it up a little bit, and we've started saying things like solve, and it's always going to be that one. And then I'll do something like for theta between 0 and 360 degrees. This was what was on our skill builder the other day. 30 degrees is between 0 and 360, but that's not our only answer. What's our other answer? 150 degrees. How'd you get that?
Unit circle.
The unit circle. Hey, you might want that thing today. Slight change in the instructions. Solve for theta between 0 and 2 pi. Pi over 6 and 5 pi over 6. Again, using the unit circle, because sine is 1/2 right here and here. Gesundheit. Change in instructions again. Solve for theta between 0 degrees and 720 degrees. We already have some of these. 30 degrees fits in this. 150 degrees fits in this. How'd you get 390? By adding 360, what are you finding? Coterminal angle. We have one additional answer, 510. Solve for all theta in degrees. When I say solve for all theta in degrees, how many answers are there? Infinite number of answers. Because every angle, coterminal to one of the original angles I found on the unit circle, will work. We've done infinite number of things before. We talked about way back in chapter 10, an infinite sequence. Back in the second part of chapter 12, we talked about an infinite number of asymptotes. To do this, we say theta equals 30 degrees plus how far apart are the answers? Let me rephrase, because you're not wrong, but not all answers are 120 apart. The 150 and the 30 are 120 apart, but if I want to continue to get answers, these ones don't have a common thing, but these ones do. 30, 390. I can keep adding a full circle. 360 degrees K, where K is an integer. Now that's half of all of my answers. That's half of infinity. The other half of infinity goes with the 150 degree angle. This will get me all of my angles. These first numbers come from the unit circle. The second number is that full circle idea to get the coterminals. Now, in all actuality, when it comes to looking at these, there's a couple of different ways we can approach the problem. There's the traditional method, and then there's the, if you know your unit circle, it becomes a lot easier method. The traditional method works with the fact that there is a pattern between how the answers for sine, for cosine, and for tangent work. when it comes to these, the angle between the solutions, from one solution to get to the next solution, it changes depending on if it's sine, cosine, or tangent. Traditionally, if you are going to solve problems like this, the original is real basic. That's what a calculator's for. To get to the second solution that works on a full unit circle without necessarily needing the unit circle, traditionally the idea is that you want to know what the pattern is for sine, for cosine, and for tangent. Sine. We've actually talked about this a little bit in previous sections. Sine has the same value at angles that have what as their pattern? The examples are 150 and 30, 135 and 45, 120 and 60. What do all of those pairs have in common? They do have the same reference angle, true. They do all have over 2. I will agree with that as well. Helps if I write down the right angle. If you knew nothing about the unit circle, you just knew that it was these pairs of numbers. What does each of the pairs have in common?
They have the same number.
True. Not what I'm going for, but not wrong. Because I could also give you ones like 117 and 63. 5 and 175.
They add up
They add up
to 180.
to 180. Every single pair adds up to 180. Sine has this feature that to get from one answer to the other possible answer, 180 is what they add up to. So that means if you want the second one, the second angle is equal to 180 minus the calculator angle. And we did actually talk about this back in the end of chapter 12. We just didn't really use it a whole lot. And I'll be honest with you, I still probably won't use it a whole lot, but it is something that if you continue on with math in the future, it might actually be easier than having the unit circle memorized. Might. I personally just go back to the unit circle. Okay, cosine. It's pairs that have the same answer. Not quite fit in the same way.
It was on there. On your little board.
I have to. Okay, cosine ones that have the same answer. One pairing is 30 and 330. Another pairing 45 and 315. They're adding up to 360. So to get the second angle, you do 360 minus what you get on the calculator. Note, this is if you're working in degrees. Y'all are smart. You know how to make the comparison to move into radians. Tangent. Okay, tangent ones that have the same value. 30 and 210. 45 and 225. 60 and 240. It's a funky looking 2. Let's make it more legible. 120 and 300. They're 180 apart. The difference between them is 180 degrees. So to get your second angle, you either add or you subtract 180. And that's because tangent has a period of 180 degrees and it doesn't repeat itself within a period. Unlike sine and cosine will hit the same value 2 places within a full period. Tangent will not. Tangent will only hit the same value once it comes back to the next period. Okay, what does this have to do with what we're actually doing? In other words, what are the problems actually going to look like today? Today you're going to be asked to solve the following. And what you're going to be given with that situation when you're asked to solve is it's going to say solve the following, and then it's going to give you an interval in which it wants all of the solutions. Because generally speaking, when it comes to real world problems and working with trig, oftentimes you're going to have this situation where you know an angle needs to be within a given range, you just don't know what it is. Because generally there's a limitation. There's a limitation on angles oftentimes because of the fact that it deals with something spinning around something and it can only spin so many times before it has to stop. And so you're limited. So, solve the following within the given range. Now, so far, as I've given you problems that have been solved using trig, it's always been a situation where it's been trig of angle equals number. It doesn't always work that way. Trig equations can build out no different than any other equation involving x. I don't ask you to solve an equation involving x where I always set it up x equals 5. Solve for x. There'd be no point. Just like trig is not always trig of an angle equals a number. Oftentimes you're going to have situations where you'll have things multiplied by the ratio or added to the ratio that you have to solve for it. And when you come across this, you can't overthink it. You know how to solve trig when it's trig of theta equals number. You know how to do that. You've known how to do that for a long time. So if I give you this, the first thing you want to do is you want to get it as trig of angle equals number. You want to get the trig alone. If I want to get the trig alone, in this case sine of theta, where am I starting? Subtract the square root of 3. Just doing PEMDAS backwards. 0 minus square root of 3 is negative square root of 3. Divide by 2. Sine of theta is equal to a negative square root of 3 over 2. Now, traditionally, at this point, we would plug into a calculator. We would do sine inverse of negative square root of 3 over 2, and our calculator would give us that this is a negative, brain, re-engage please, negative 60 degrees. Is negative 60 degrees even close to the angle range?
Nope.
No. It's in the wrong units. And even if I convert it to radians, it would be negative, which is not between 0 and 2 pi. So, traditionally, what would you do at that point? You would find a coterminal angle. And then you would work with the fact that in degrees, they'll have a sum of 180 degrees. Or the easier way is, I give you a unit circle for a reason. Where is sine? Negative 3 pi over 2. 4 pi over 3. And 5 pi over 3. Because those are the angles between 0 and 2 pi. Because 0 to 2 pi is the unit circle. And most of the time, it's going to be number of angles on the unit circle, so the unit circle just tends to be easier. Those are my answers. Two tangent of theta plus 1 equals tangent of theta. First thing I need to do is I need to get it where it's trig equals number. Not trig getting multiplied by a number, adding a number equal to more trig. Thoughts on where to go with it? Minus what? Absolutely. Now, some of you are probably not necessarily seeing that quite as quickly, and that is okay. General rule of thumb. If seeing what to do next is a challenge, change your trig to a variable. Start there, and then change it back. Since these are both tangent, I can change them both to the same variable, and this would be like starting with the equation that looks like this. Do y'all know how to solve 2x plus 1 equals x? Yeah. You'd either subtract the x and then subtract the 1, or subtract 2x and then divide by a negative 1. It doesn't matter either way. I personally prefer the latter. 1 equals negative x. Divide by negative 1. X equals negative 1. But then you have to remember that it was never actually x. X was a placeholder for tangent. So what I actually have here is tangent theta is equal to negative 1. Keeping in mind that tangent is not what I'm trying to solve for. I'm trying to find theta. So now I have to look for theta, but that's where the unit circle gets involved. Where is tangent equal to a negative 1? For all theta in radians. So first off, make sure that you're looking at the right units. 3 pi over 4. 7 pi over 4. Okay, so I've got the right units. Am I in the right range? Not quite. I want all theta in radians. To get all theta, I take my answers and I add, remembering how far apart are answers always? A full circle. Regardless of which trig ratio it is, you can always use a full circle. What's a full circle in radians? 2 pi k. Where k is an integer. Theta equals 7 pi over 4 plus 2 pi k is my other answer where k is an integer. Yes, you must tell me k is an integer every time. Now, in all actuality, some of these can be simplified down. You don't necessarily need this many answers. This is a beautiful example of one because 3 pi over 4 and 7 pi over 4 have this feature of being a half circle apart. And if they are a half circle apart and then I keep adding whole circles, would you agree with me that whole circles are multiples of half circles? So sometimes this can be simplified down. You do not have to. But one thing you can do is if you notice a pattern where the answers are always like a half circle apart, or if you have every quarter circle or every third of a circle, no, you have to have everyone in those. You can simplify these down to one answer that says theta equals 3 pi over 4 plus pi k, where k is an integer. Because then it's saying the answers work for every half a circle because that's what pi is. If that didn't make sense to you, it's okay, you don't have to do it. And I wish I knew a better way to explain it, but I don't. I've not found a great way to explain when it simplifies and when it doesn't. But this is an alternative answer, and it would be a single answer instead of 2 answers. And yes, you need all of them. Okay? Let's ramp it up a little bit. Cosine squared theta minus 2 equals negative cosine of theta. Is it obvious on what to do? If it's not obvious, generally I recommend switching it over to variables. It's all cosines, which is nice. And it's all of the same angle. If it's different angles, we got a problem. Then we got to use a trig identity. Yes, identities do get mashed into this. Howdy Monday. Unfortunately, yes. I'm planning on trying to get some supports together. Okay, but if it's the same trig ratio, it can all become the same variable. If it's multiple trig ratios, they become different variables. If it's a trig ratio of different angles, they would be different variables, but then you generally want to deal with the different angles before changing it to variables. So having an equation like cosine squared minus 2 equals negative cosine of theta is equivalent to having an equation that says x squared minus 2 equals negative x. It is quadratic. And to solve a quadratic equation, you have a couple of options. Factoring is one of them. But in order to do that, it must first be equal to 0. I like my x squared positive, so I'm going to leave that there. If the x squared was negative, I'd move everything to the other side, even if it's more movement. Make sure you're not combining unlike terms. When factoring, I have to be careful if it's the full AC method or it's shortcut. Or sometimes it's just greatest common factor. Greatest common factor here is 1. This is quadratic trinomial, so either AC or shortcut. Do I have to do full AC? No. I can do the shortcut whenever what is true? The leading coefficient is 1. The x squared has to have a 1 or an invisible number in front of it. If it has anything other than 1, including a negative, you cannot do the shortcut. You have to do the full AC method. Okay. By the way, what are other ways to solve quadratic equations? Quadratic formula. That's a thing too. Is it going to be a very often thing?
No.
2 things that multiply to negative 2, but when I add them, I get 1.
-2 and 1.
Positive 2, negative 1. So, x plus 2x minus 1. Remember, if you're doing the full AC method, you do not jump directly to those parentheses. You have to do the rewrite step where you write it as 4 terms, and then do factoring by grouping, where you factor the first half, factor the second half. Okay, so that means x equals,
92.
yep, because I set each of these individually then to 0, and x is negative 2, and x is 1. But remember, it wasn't x. X was a placeholder to help us. By the way, you don't actually have to change to x's. If factoring, when it stays a cosine, makes sense to you, go ahead and do that. X was a placeholder, in this case, for cosine. Cosine is negative 2. When it's not a number on the unit circle, you might have to use your calculator, because there are going to be some numbers that aren't on the unit circle, and then you're going to have to use the calculator, and then you're going to have to work with these patterns. Negative 2 is not on the unit circle, but that's for good reason. So what is cosine inverse of negative 2? Non-existent, because remember, what is, how high and how low does cosine go when it's graphed? Up to 1, down to negative 1. Is 2 anywhere in that range? No. 2's outside of its range. It doesn't work. If this was my only answer, I would be writing, would it be undefined or no solution as an answer?
No solution.
No solution, because I'm asking you to solve. But this isn't the only one. Remember, cosine was equal to negative 2, but we also have cosine of theta equal to 1. I can use a calculator on that. I don't have to. The unit circle gets 1. Where's cosine 1? 0 degrees and 360 degrees. This is one of the most common errors I see in solving, is that people will get the 0 or they'll get the 360, but they won't put both. Pay attention to your range. Does your range want both? Yes. If this was not or equal to right here, if it just said 0 to 360 but not including 360, you would just put 0. But since it included both, you need both. Remember the skill builder? The one problem that stumped some of y'all because it was 0 and 2 pi? Be careful of that. That is the range I wanted, so I'm going with it. Oh. Did you know that the alphabet goes A, B, B?
Yep, I was going to tell you.
After, like, BB. They're good initials.
I think you did that one, like, whole notes you made. It just meant after that now.
Yeah.
But I was going to tell her, because...
What can I say? BB is the way to go. I can't make excuses for the other ways. For those of you who don't know, my first name is Brittany, by the way. Yeah, BB. Okay, but anyway, next problem. Tangent squared is equal to 1/3. Tangent's not alone. It's got a squared on it. How do you get rid of a squared?
Square root.
You square root it. If you need, you could have switched it to this.
Oh, you square both.
You square root one side, you square root the other. Being careful. that when you introduce the square root to a problem,
Positive and negative.
you need the positive and negative. So I have a positive and negative square root of 1/3. To square root a fraction, you square root the top, you square root the bottom. 1 over square root of 3. To which people often then come to me and say, Benson, I can't find 1 over square root of 3 on my unit circle. Rightfully so. Remember, our unit circle is fully simplified. Is that?
No.
No, it might not be a final answer. And generally, you don't need non-final answers simplified except when you're trying to use something that has all the simplified things to get your final answers. I rationalize my denominator. Positive, negative, square root of 3 over 3. But it wasn't x. That's one of the other common things that I see people do is they forget to change it back and actually finish solving. Tangent of theta is equal to a positive and negative square root of 3 over 3. Theta equals pi over 6 because pay attention, my range is in radians. Theta is equal to 7 pi over 6. Theta is equal to 5 pi over 6. Theta is equal to 11 pi over 6. I looked for every single place on the unit circle that tangent was either a positive or a negative version of square root of 3 over 3. Our final example we're going through today. Sine theta cosine theta equals negative 1/2 cosine theta. A problem like this causes some of the biggest issues outside of just regular algebra skills. Because when we come across a problem like this, some people have an automatic instinct of how to approach this problem, and you can do it that way, but you have to be careful of something. Any thoughts on how you would start this problem? That is not the way most people do it. But yes.
Move over the sun for the cosine.
That is what he was saying, yeah. Move over the cosine. Does anyone have any other first instincts? Maybe if I change it to x and y, because I promise you someone will do this. There are a couple different ways to do this. One way, absolutely, is to move things over and factor, and it's honestly the better way. The reason I'm trying to emphasize this way first is because every single year, whether I teach it or not, someone does this, and then they lose things because of it. Okay, oftentimes what people try to do is they try to say, well, you can divide both sides by y. And in a way, can you? In a way, you can. You end up with x is equal to a negative 1/2. Because instinctively, you guys have been taught divide things off if you see it on both sides. The only problem with that is what if y is equal to 0? If y is equal to 0, you can't divide by it. Dividing by 0 is undefined. But you have to be careful of this method. If you're going to do this method, and some people always do, it's why I have to talk about it. If you're going to do this, you have to break up the situation into two cases. One case in which y is not 0, and then the only answer is x is equal to negative 1/2. The other case is you say, well, if y is equal to 0, that also works. Because if y is 0, then this side becomes 0 and that side becomes 0. I honestly do recommend the second way that magically was first recommended and very rarely is ever actually even thought of, so bravo. Generally speaking, get it equal to 0 because you can factor. xy plus 1/2 y is equal to 0, and you can factor out a y. In other words, I got it equal to 0 and I factored out the cosine. In a factored form, you set the factors equal to 0 when it's equal to 0. You'll get the same things as what we did the other way, y equals 0 and x equals negative 1/2. Remembering that y was cosine and x was sine. Where is cosine 0? 90 degrees, 270 degrees. Where is sine and negative 1/2?
330.
330 degrees. And 210 degrees. Is that the range in which I wanted the answers? No, I wanted for all theta in degrees. So what do I do to get my final answer? Plus 360k. Where k is an integer. To all of them. In all actuality, these first two could have been simplified down to 90 plus 180k, but you don't have to do that.